And now with the new lesson about lines of symmetry. It says here that a shape has a line of symmetry if, when that shape is folded over the line, the two halves of the shape match up exactly. And this is exactly what we tried today in class when we had that rectangular piece of paper. We found that when we made the rectangular piece of paper a square, we found that it had a line of symmetry this way here. Which means that if I folded the shape into two, if I folded the shape over this line of symmetry, the two halves will match up exactly. And we also found that if we just have another line of symmetry, or if we folded the paper over this line of symmetry over here, the two sides will match up also exactly. And we found also that's when it was a square, not a rectangle. We found also when it was diagonal, whether this way or the other side here, both of them, it means that the square, if I fold it over any of the diagonal lines of symmetry that we have over here, both sides or the two halves of the square will match up exactly. And we came up with the conclusion that any square in the world has 4 lines of symmetry. Okay? So this is just a piece of information that we need to know, and we need also to understand how we can draw the lines of symmetry on a square. Okay, if I just rotate the shape this way, it doesn't mean anything, it's just still a square because it has here 4 right angles. This is the most important thing about a square. You need to study this, guys. The most important thing about a square is that it has 4 equal sides, like all of you know, and 4 right angles. If I move to the next slide over here, we're going to find here us dealing with rectangles. In a rectangle, we agree that it has, yes, we can just draw a line of symmetry over here, because if I fold the shape over this line of symmetry, they're going to match up exactly. And here, if I folded the shape over this line of symmetry, they're going also to match up exactly. But if I folded the shape over this line of symmetry, they will never match up exactly. Yes, it seems like they will match up. If you just look at it, you're going to find, oh, mister, it is actually possible. Just by looking at it, it seems like you will be able to fold it and the 2 parts will match up exactly. But we tried this in class today and we found that it is impossible to fold a rectangular shape over this line of symmetry and the 2 halves match up exactly. It is impossible. So we came up with the conclusion that a rectangular shape has only 2 lines of symmetry, and this was the conclusion. A rectangle has only 2 lines of symmetry. All right, good. Now we're done with squares and rectangles. What about triangle? All right. Triangle, as all of us know, it has 3 sides, but we have 3 types of triangles. What are they? We have an equilateral triangle. You need to know this, guys. Equilateral triangles. Equilateral triangles means that all the 3 sides of a triangle are equal. Again, please, you need to study this. An equilateral triangle, all the 3 sides are equal, and in this case, you can draw 3 lines of symmetry. 3 lines of symmetry. All right, so they get changed over here. Okay, so how can we draw them? You can draw the 3 lines of symmetry because you will be asked to draw the lines of symmetry on a shape. If it's rectangle, for example, we agreed here in the middle vertical and here also horizontal, and there is no other way. Okay, under the rectangle, you just take it from the 3 angles that you have, the 3 vertices. I have here a vertex, so this is an angle. You just start from it and you start to just putting it, you start drawing the line and you put it here this way. Another line of symmetry this way from this angle, and it goes straight away this way. You try to make it, of course, in the half exactly. And here another line that comes from up there and it goes down also straight. So an equilateral triangle has 3 lines of symmetry. But what about this? It has 2 equal sides. Guys, you see this line here, and this has the same? It just means that this side is equal to this side. Both of them, it has only 2 sides that are equal. That's why we call it an isosceles triangle. It's only 1 line of symmetry. An isosceles triangle, you just draw it over there from the top and it goes down. An isosceles triangle has only 1 line of symmetry. But what about a shape that doesn't have any equal sides? The 3 sides are just different, they're not equal. We call it a scalene triangle. And a scalene triangle has 0 lines of symmetry. 0 lines of symmetry. Okay, so this is one thing that you need to study all this information, and you start also writing them and you keep studying them before practicing. All right, let's go to the other part of the lesson, which is a shape that has 4 sides. Here, 4 sides, 4 sides, 4 sides. What do we call all of them? We call them quadrilaterals. So all of them are just quadrilaterals. This shape, we call it a parallelogram. This is a parallelogram, and you need to know the difference between a parallelogram and the other shape here, which is a rhombus. Okay, a parallelogram here, it says, this is for your information, you need to study this. The difference between a parallelogram and the rhombus is that a rhombus has 4 equal sides, while a parallelogram has only 2 pairs of equal sides. So here, all the sides are equal. Here, only the opposite sides are equal. This is why this is a parallelogram and this is a rhombus. All right, great. Now we know the difference between a parallelogram and a rhombus. What about the square? Mr. Ahmed, a square also has 4 equal sides, exactly like the rhombus. How can I know the difference? Well, the only difference is that in a square, the 4 angles are right angles, but in a rhombus, 0 right angles. And this is here the second line. The rhombus and the square have 4 equal sides, but the rhombus has 0 right angles. And the last shape that we have over here is a kite. Okay, let's now talk about the lines of symmetry with these 4 quadrilaterals. If we talk about the parallelogram, you just need to know it that it has 0 lines of symmetry. So a parallelogram, which has here 2 opposite equal sides, not all the 4 sides are equal, it has 0 lines of symmetry. But about the rhombus over here, the rhombus has 2 lines of symmetry. Let's draw them together. The 2 lines of symmetry, we go this way exactly because you are asked also to draw the lines of symmetry, to learn how to draw the lines of symmetry of rhombus or any other shapes. Yes, this way. These are 2 lines of symmetry with the rhombus. About the square here, as we agreed earlier, the square has 4 lines of symmetry, and this is how we draw them. And about the kite, as we agreed in class, it has only 1 line of symmetry, and it goes this way, which means that if I fold this shape over this line of symmetry, the 2 halves of the shape will match up exactly. All right. And this is about the quadrilaterals. So this is everything about the quadrilaterals. Of course, you might find some shapes that are not discussed here in this video, and then you will have also to think about them and try to find out, and this will be practiced more later. All right, the next slide here is about circles and an oval shape. As we agreed in class, a circle has just endless lines of symmetry. So you cannot just count them. It's only 1, 2, 3. It's infinite. So it is endless line of symmetry, endless number of lines of symmetry. But while an oval shape has only 2 lines of symmetry, where are they? Here they are. Only 2 lines of symmetry, and this is how we draw them. You need to study all of this. All right, so here we have a line of symmetry that comes this way. If you fold the shape over this line of symmetry here, they will both match up exactly. The 2 halves will just match up exactly. And if I have this line of symmetry here, if I folded the shape over this line of symmetry, the two halves also will match up exactly. All right. Now it's about shading. They're giving you here a question asking you to shade 5 more squares to have 2 symmetrical lines. So here we have 2 symmetrical lines. So they need you just to use 5 more squares, or shade 5 more squares to make them look exactly the same. But there is just here a question, there is a mistake, we need to take that square down. That's it. Alright, so this is the question here. They're giving you this, and they're asking you to shade 5 more squares to have 2 symmetrical lines. Alright, no problem. If I were you, I would just take the first square and shade this part here. And the second, I put it here. And then the third, I just take it and put it there. The fourth, I put it here. And the fifth, you put it here. Now the 2 lines of symmetry, the 2 lines that we have here are symmetrical lines. They do, if I fold this half over this line of symmetry, they're just going to match up exactly with the other half. The same thing exactly if I fold this half here over this line of symmetry, they will going to match up exactly with the other half. Alright, the next part over here is if I'm given a shape like this. This shape actually is just a composite shape that consists of how many sides? 6 sides, which makes it a hexagon. So this is a hexagon. And they ask you to find or to draw the lines of symmetry. These are the only 2 lines of symmetry that you can find. Because if you try anything else, like for example, if someone just thinks, oh, I'm gonna draw a line of symmetry over here, no way. If you try to fold this there, you're gonna find this vertex here, going to go over there. They're not gonna match up exactly. So the last line of symmetry is wrong. It has only 2 lines of symmetry. This is how. Now with another lesson, which is reflection. Reflection is the flipping of a figure or a point over a line of reflection, which is called the mirror line. And this line here is what we call the mirror line. So to reflect, we just need to look at the vertices or count the vertices that we have. How many vertices do we have? A vertex is just that top here of the angle. That point is called a vertex. You see this? This is called a vertex over here. This is a vertex. This is here another vertex. Another vertex is here. And this is the 4th vertex. So we have 4 vertices, and vertices is the plural form of vertex. Alright, so we have here 4 vertices. We need to reflect them on the other side of the mirror. How can we reflect them on the other side of the mirror? The first vertex here, as you see, it's on the mirror exactly. If it is on the mirror exactly, then it's going to stay there on the mirror exactly. Then I put a point there. This is the first vertex. It's going to stay the same place exactly. But the other vertex over here that we have, alright, we need to count how many squares it is away from the line of symmetry. Here you find it's 1 square, 2 squares, 3 squares, 4 squares. It's 4 squares away from the line of symmetry. Then I need on the other side of the mirror 4 squares. 1, 2, 3, 4 squares also here away from the mirror on the other side. So now I need to match these 2 points to draw this side on the other side of the mirror, or to make the reflection. Good. You need to use a ruler and a pencil. Alright, but I'm gonna use actually another color. I might use here, alright, let's make it blue. Right. Well, I'm not done yet because you still have other 2 vertices. Alright, this one here is 1 square. You need to count the squares this way, alright? So here it's 1 square, 2 squares, 3 squares, 4 squares away from the mirror. So I need to start it from the mirror to the other side. I need to count also 4 squares. 1 square, 2 squares, 3 squares, 4 squares, so it stays here. Then I'm just going to remove this and I'm going to put over here the other vertex, and I will just connect them. All right, please guys, it needs to be clean. Even if you're trying to count the squares at the end, you need to rub them. I just need the shade, the reflection to be clean. All right, the fourth vertex, which is the last one here, it's only 2 squares away, so I need it also to be 2 squares away on the other side. The same line, so 1, 2. I need it 1, 2. It needs to become here. It needs to become here, and then I connect the points over here. And then you just take it to the other point there. That's it. Now this is the reflection of this. So as you see guys, this is what I did. I just saw how far each vertex, you just first counted the vertices. I have 1, 2, 3, 4 vertices, 4 points, 4 angles. Then I just draw each vertex each vertex just at once, just separately, and then I connect them. Let's do this, but here I don't have a line, a mirrored line, a vertical line, a vertical mirrored line. No, I have here a horizontal mirrored line. The same thing exactly, but instead of going here this direction, here I'm gonna go this direction. All right. To do this, let's do the first vertex. I have 1, 2, 3, 4 vertices again. Then I need to do the first one. It's 1 square away from the line, 1 square away from the mirror line. Then I need also on the other side of the mirror 1 square away. 2 squares, 1, 2 squares. Then I need 2 squares, 1, 2 squares away from the mirror. Here I have 1, 2, 3, 4 squares. Then I need 1, 2, 3, 4 squares away from the mirror. Now you can connect them. All right, like this, and then I connect that. Let's continue. I have here the 4th vertex, which is 1 square away. Then I'm going to get my pencil again, and I just draw it over here. Now you connect them here, and the last side you draw it is here. And this is exactly the reflection of this shape over a horizontal mirror line. The last one over here, if I have a shape that needs to be reflected but over a diagonal mirror line, like this one here, no problem. The same thing that we did exactly over there, but I'm going to count also diagonally. So this way, I'm going to count this direction. So here I have 1, 2, 3 vertices. I need to reflect the 3 vertices, then I connect them. So here this one is how far is it from the middle line? It is only half a square. This is only half a square. No problem. So it's half. Then I need to go the other side also half away. Exactly the same. Look at how it's going. It's not going now this way. It's not going to go this way. Horizontal? No. It's not going to go this way. Vertical? No. It's going to go diagonal this way. Exactly. I'm going to keep counting this way, as many as I need. So here I have only half a square until I reach the middle line. Then I need also half a square here. Then the point becomes here. All right, what about the other vertex? I need here, you count also diagonal. I don't go this way. You don't go this way. Wrong. You don't go this way. Also wrong. All I need to do is that you go diagonal this way. So it's 1 square, 2 squares, 3 squares until it touched the middle line. Then I need to go after the middle line also 3 squares. So 1, 2, 3 squares. You stop here. Okay, so this is going to be the point. Okay, now I need to connect them. And done. What about the third vertex? You need to count. Also vertical. Everything, diagonal. Everything goes this way. Doesn't go this way or down. Not horizontal, not vertical. It goes diagonal. So 1, 2, 3 squares exactly. Then I need 1, 2, 3 squares exactly. Then the point stays here. Becomes here. So I want to make sure that I didn't get confused. Yes, here. Then, if you connect to the points, you're going to find that this is exactly the reflection of the other shape through this diagonal mirror line.